Hello, everyone. Thanks for having me here. So I'm going to present the work of my team, which is Mustafa, Badi, and me, Beltrán. But since we don't have a lot of time, I'm going to do it myself. So when we started this competition, we were presented with very few data, the test data, and no training data, which is quite an unusual thing in machine learning. So we had two tasks initially, which was analyzing the data we had at the moment and gathering new one. And so first, before gathering any new data, we start analyzing the test data. And as you can see in these figures, we found out that the data set was quite unbalanced. Almost the vast majority of the users were one-time requesters. They only did one request in this test set. And there was very few representation for users doing more than one request. And for other parameters like city or language, we had, as you can see, very popular cities as Paris, obviously, Amsterdam, and other cities that are underrepresented, and same for language. And then for the date parameter, which is quite, it was kind of the hardest parameter to understand. And the half of the dataset is only lies in dates from 0 to 6. And this is interesting because it's probably due to the fact that in the sooner dates, the stock is intuitively smaller, and thus the prices will be either higher or at least will have a highest variation between them. And also we found that there's even a lot of dates without representation in the test set. For example, maybe from dates to 17 and 18, there's not a big difference on the price. So after that, we started gathering our data, and we had different strategies through time. First of all, we started doing random queries to get an overall representation of the data and a general idea. And just after that, we tried to detect bias in language and mobile parameters. And for the case of mobile, the way we tried to detect this bias was doing the same exact queries, for example, same city, same dates, same language, and just changing the mobile parameter or combinations. And so for the mobile parameter, we found out that there's no bias. Doesn't matter which platform you use, that there's not a big change. So it's quite an informative feature. We can avoid it. But for the language, we successfully detected the bias. For languages like Finnish or Norwegian, the prices were very high. And the lowest prices were for languages like Hungarian, Bulgarian. And our models were able to interpret this well. After that, we tried to make our data a bit more similar to the test set to try to improve our scores. And we took queries from the test set and do small changes in them, like adding one, or summing or subtracting one to the date to see these slight changes. But the creators of the API seem to be very clever, and they kind of pretended this behavior, so we weren't really getting the information we wanted. So after that, we tried to continue detecting more bias in this data set, and we tried to address the problem of the dynamic pricing, as my colleague said, and the user behavior. And what we did in this case was doing simulating like a history for the users. For example, you can see here that both user 1 and user 2 are requesting, they want to go to Rome, they speak the German language, and they use their laptops. But the user 1 just requested on the date 7, whereas the user 2 had been requested for a long time in date 40, 25, 12, and after 7. So it clearly has more interested, it has been more interested over time in going here. So the prices will be, the intuition would be that the prices would be higher for it. But in practice, what we find out is that these price rises are kind of random. We couldn't find any pattern on it. We couldn't, it didn't have anything to do with the city, with the language, with the number of requests. So it was quite hard to address this dynamic pricing. So, okay. After we started gathering more and more data, we tried to do some feature engineering on it to expand the feature space and see if we could add more information. So first thing was adding features about hotel availability. So I don't know a lot of things about economics, but our intuition was that the availability and the stock of the hotels has a big impact on the prices of the rooms. So we tried to give more dimensions to this stock. We modeled the number of full hotels in the cities for some dates, the median stock, the total stock in that city for a date. As I said before, we also tried to introduce the user history and the user behavior. And lastly, we did some ML techniques, clustering and PCA. If you're not familiar with them, clustering, we try to, with clustering, you group the data, the similar data, so we try to find underlying groups. And PCA is a good manner of finding linear combinations on our data. So in terms of modeling, we tried everything we knew and more. Stack regression, which stacks different models and then outputs a linear combination of them. CatBoost and XGBoost, which they are very popular in these kind of competitions and have a very good press. Random forest and decision trees, because they are very informative. They are a very good way to interpret and analyze the results. And an MLP regressor, which is a simple neural network. So these were our results. We gathered a lot of data, and our best results were finally the CatBoost and the MLP models. And we did this thing that is also very popular in these kind of competitions, which is model averaging, which is very simple, just averaging your best results. And it gave us an RMC of 19. So quickly, I'm going to finally tell us our conclusions of both teams about this competition, what we learned. So in these kind of competitions, data is the most important thing, or one of the most important things. If you don't explore, understand, and prepare properly your data, you have nothing to do. Also, regression tasks prediction of prices is very interesting, because if you are not very familiar with machine learning, almost everything is about classification, but this is also interesting, or at least I hope you found it that way. Also, sometimes simpler is better. You don't have to go for the fancy things to get good results. And lastly, we learn as we build, which means that theoretical background is obviously important, but sometimes when you put these things into practice, you add another dimension to your knowledge, and it's very crucial. So thanks for your time, and that was it.